Okay, in the last class we have discussed about the Vesper theory. In the last class we are discussing about the Vesper theory. Remember?
Yes.
So today we are going to describe the shapes of some covalent molecules based on the Vesper theory. So first is our methane. What is the formula for methane? Methane is CH4. Okay. Now you have to tell me the geometry, the shape of CH4. How we can identify the geometry of CH4. So it has 4 bonding pair of electrons surrounding the central carbon atom like this, CH4. One hydrogen is above the plane, so we represent it by wedge, and one hydrogen is below the plane, so we represent it by dash. The equal repulsive forces of each bonding pair of electron results in a structure with all HCH bond angle. This bond angle, this bond angle, this one, they all are 109.5 degree. Okay, as I told you that this angle is the tetrahedral angle. So we call this structure as tetrahedral structure. So what is the geometry or shape of methane? So it is tetrahedral structure. And what is the hybridization? Hybridization is sp3. Okay, because hybridization is sp3 because carbon is forming 4 bonds with the hydrogen. Okay, and hybridization is calculated only by single bonds, sigma bonds. So one sigma bond is this, one sigma bond is this, 2, one is this, 3, and one is this. 4 sigma bonds are there. Okay, 1 from S and 3 from p orbitals. They mix together to form your tetrahedral structure. So this, you can see, this is the structure of CH4. Bond angle is 109.5 degree. Repulsions are equal. That means the atoms are arranged so far apart from each other to minimize the repulsion, which is the basic fact of your Vesper theory. To minimize the repulsion, your atoms are arranged. Okay, so this is a Lewis structure, electron dot structure of methane. Carbon is having 4 electrons in the outermost shell. Hydrogen is having 1 electron. Hydrogen completes its duplet and carbon completes its octet. So these things you have to remember. The methane shape, it's tetrahedral. Bond angle 109.5 degree. Hybridization sp3. Okay, and the structure. So please draw it. Next in your syllabus is ammonia. So what is the structure of ammonia? It is pyramidal structure. The structure is pyramidal. H and H bond angle is 107 degrees. Okay, so we make it like this. Nitrogen, its atomic number is 7. Its electronic configuration would be 2, 5. That means there are valence 5 electrons. So one is this hydrogen, one is above the plane hydrogen, one is below the plane hydrogen. 3 electrons are involved here and one as lone pair. Okay, total of 5 electrons like this. So you can see that it has 3 bonding pairs of electrons and one is lone pair of electrons. Okay. Then your as lone pair bond pair repulsion, it is greater than bond pair repulsion. So the bonding pairs of electrons are pushed closer together. We have studied that lone pair repulsion is greater than lone pair bond pair and then bond pair. So here lone pair bond pair repulsion, it is greater than bond pair repulsion. The bonding pairs of electrons, they are pushed closer together. So that's why its shape is pyramidal and the bond angle is 107 degrees. So this structure is called pyramidal. And what is the hybridization of NH3? So how many sigma bonds are there? Tell me in NH3 how many sigma bonds are there?
Three bonds.
Yes. We have 3 sigma bonds, 1, 2, and 3. And but in hybridization, we count lone pair of electrons also. We do not count the pi bonds, we count lone pair of electrons. So its hybridization is also sp3. Okay. Hybridization is also sp3 and the hybridization of the methane is also sp3. But there is a difference in the molecular shape. It is tetrahedral. For methane, it is tetrahedral, and for ammonia, it is pyramidal. Because in methane, there is no lone pair, and in ammonia, there is 1 lone pair. So this creates a difference in the molecular shape. Is it clear?
Yes.
And also bond angle. In the methane, it is 109.5 degrees. But in ammonia, it is 107 degrees. Although the hybridization is same in both the cases, sp3, because of lone pair, bond pair repulsion. Okay, here lone pair bond pair repulsion is greater than bond pair repulsion, and when repulsion is greater, then it decreases the bond angle. Is your ammonia is done, methane is done. Next is water. So water, the formula for water is H2O. Okay, its shape is like this, H2O. How many bonding pair of electron it have? Two. One is this and one is this. So it have two bonding pair of electrons. And how many lone pairs of electrons does oxygen have? So for that you have to write down the electronic configuration for oxygen. It is 2, 6. So here one electron is involved here in bonding, one electron is involved here in bonding, and two lone pairs exist, 1, 2, 3, 4, and 5 and 6, right? So it have two bond pairs and two lone pairs of electrons. The greatest force is between the two lone pairs. This results in the bonds being pushed even closer together. The shape of the water molecule is non-linear V shape, or you can say bend shape. It is non-linear V shape or bend shape. The bond angle is 104.5 degrees, and if we talk about hybridization, it is also sp3. Okay, because we have two bond pairs and two lone pairs. Total is 4, right? So 1 from s orbital and 3 from p orbital. So hybridization is also sp3. Bond angle is 104.5 degrees. So we can see how it decreases from 109.5 degrees of the sp3 angle because of the repulsion in the lone pairs. Okay, when lone pair repulsion occurs, it causes a decrease in the bond angle. Okay, so this is the greatest repulsion between lone pair and lone pair. Intermediate repulsion between lone pair and bond pair. Bond angle is 104.5 degrees, and these are my lone pair 1, and this is my lone pair 2. Two lone pairs. Is it clear?
Yes.
Write it down. This is your boron trifluoride, BF3. It is an electron deficient molecule, so draw its electron dot structure. We'll find out that boron, after sharing one electron from all these three fluorines, still it is having only 6 electrons in the outermost shell. Okay, not 8 electrons. So it is electron deficient. It has only 6 electrons in its outer shell. Thus, three bonding pairs of electrons, they repel each other equally, and the bond angle are 120 degree. This bond angle is also FPF 120 degree. This is also 120 degree, and this is also 120 degree. So what is the shape of BF3? It is trigonal planar. It is trigonal planar. Trigonal planar means it is having three angles. Okay, one angle is this, second is this, and third is this. So it is in the plane. So you should remember all these things. What is the hybridization of BF3? Count the single bonds and the lone pairs. There are 3 sigma bonds only, no lone pair, right? 3 sigma bonds, that means sp2. 1 from S and 2 from P. Is it clear?
Yeah.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Right? So carbon dioxide is like this, O double bond, C double bond, O. So it have 2 carbon oxygen double bond, no lone pair, because all the carbon have only 4 electrons in the valence shell which are involved here. So there are no lone pairs. Okay. Now oxygen atoms are placed such that there is minimum repulsion between them, and the bond angle is 180 degree. OCO bond angle is 180 degree. Shape is leaf. What is the hybridization? Tell me the hybridization of CO2. Count the number of sigma bonds and lone pair. How many sigma bonds are there in CO2?
Um,
Hmm?
2.
Yes. 2 sigma bonds are there. No lone pair, 0 lone pair. So the hybridization would be sp. 1 from S and 1 from P. Sp. So draw it. molecule is phosphorus pentafluoride, that is PF5. Okay, so if you see the electronic configuration of phosphorus, it would be 2, 8, 5. All the 5 electrons are involved in bonding with chlorine, so there are no lone pairs. Okay, so its structure is this PF5, trigonal bipyramidal structure, where these 2 fluorine atoms are known as your axial bonds, which are axial, and these 3 fluorine atoms are known as equatorial. There are no lone pairs in PF5. Let us read what it is written, that it have 5 bonding pairs of electrons. It have no lone pairs. Repulsion between the electron pairs, it results in a more stable structure, being one where 2 pyramids with bases of 3 angles are joined. That is why it is called TBP structure, or trigonal bipyramidal structure. 3 fluorine atoms, they lie in the same plane as the phosphorus atom. Bond angles FPS within this plane are 120 degrees. 2 fluorine atoms lie above and below this plane are 90 degrees to it. Look at the structure. Here, 3 fluorine atoms, this one, and this, it is lying at an angle of 120 degrees. And 2 fluorine atoms, which are axial, they are lying perpendicular. That means they are lying 90 degrees to each other. The bond angle I am talking about, FPF. Okay, so it is 90 degree. It is also 90 degree. Okay, so the structure is structure is trigonal bipyramidal. Tell me the hybridization of this. What is the hybridization? Count the number of sigma bonds and the lone pair. There are how many sigma bonds?
Can you please switch to the diagram?
Sorry, this is the
Can you
diagram.
please- There are 5 sigma bonds.
5 sigma bond. That means 1 from S, 3 from P, 4, and 1 from D. So the hybridization is sp3d in trigonal bipyramidal structure. Right. Sulfur hexafluoride, SF6. So it have 16, 2,8,6. All the electrons are involved in bonding with chloride, so there are no lone pairs. Equal repulsion between the electron pair results in this structure, and the bond angles are 90 degrees. We describe this shape as octahedral. The shape is something like this. So tell me the hybridization of this SF6.
I think it's SP3.
SP,
3.
then
D.
it only becomes 5, right? 1 from S, 3 from P, and 1 from D. But there are 6 sigma bonds, 1, 2, 3, 4, 5, and 6. So it is sp3d2 hybridization. Okay,
Okay.
right. The last molecule, you have to remember all these things. First is their molecular shape. Second is bond angle. Third is how many bond pairs and lone pairs they are present there. And the fourth is your hybridization. And the fifth is you should know how to draw them, what is their molecular shape, and how to draw their electron dot structure. Done?
Yes.
These are your homework questions. I hope you can do it. Question number 1 says that aluminium chloride and ammonia, they are both covalent molecules. So question number 1 is that draw a diagram of an ammonia molecule. Okay, you can easily draw, you can tell its shape, show any lone pair of electrons. Second part, state the bond angle in ammonia molecule. We have already learned it is 107 degrees. B part, explain why ammonia is a polar molecule. Okay, due to the electronegativity difference between nitrogen and hydrogen. Question number C, an ammonia molecule and an aluminium chloride molecule can join together by forming a coordinate bond. We have read what is a coordinate bond, right? So you have to explain how a coordinate bond is formed when one atom shares both its electrons, right? Question number 2, draw a dot and cross diagram to show bonding in the compound formed between ammonia and aluminium. chloride. So you have to use dot for nitrogen and for the not for a aluminium electron, and cross for hydrogen and chlorine electrons. Next is that aluminium chloride molecules join together to form a compound with the formula Al2Cl6. That means it dimerizes to form Al2Cl6. We have to draw a discrete formula showing all the bonds to show the bonding in one Al2Cl6 molecule. So this we already have covered. We have to do it. Show the dative covalent bonding by arrow. Okay. So arrows, like you can show it like this. That means this atom is sharing both its electron and this atom is accepting both its electron. So have you taken the screenshot of this?
Yes.
Now the last topic is our van der Waals forces. Okay, so van der Waals forces is what? They are the weakest forces basically. It is a general term to represent all the intermolecular forces. Ionic bonding is the electrostatic attraction between positive ions and anions in an ionic crystal lattice. Covalent bonds are formed when outer electrons of two atoms are shared. Ionic bonds are strong. It takes a lot of energy to break them. Okay, ionic bonds are strong. Another strong bonding is metallic bonding. Although the atoms within molecules are kept together by a strong covalent bond, but the forces between these covalent molecules, they are weak. And these weak forces are known as van der Waals forces. So van der Waals forces, it is a general term which is used to describe all the intermolecular forces. So this we will study. The types of van der Waals forces we will study in the next class. So write it down about van der Waals forces.